Hello, everybody. Thank you so much for attending another webinar as part of our series. I'm still getting used to the Teams live events. It's a little interesting when you're kind of just looking at a screen and hoping that everybody is able to listen to you. But I have my lovely assistant Justin Shade, who is giving me a thumbs up on the screen, telling me that he's able to hear me and that things are going well. So I imagine that the rest of you are as well. So thank you very much for joining us today. Today I'll be taking over the presentation role, and I'll be talking a little bit about the management of a wireless deployment, and I'm going to focus it on an AGV example. So it's not going to be exclusive to AGVs and I'll get to what that term means. It means an automated guided vehicle, for those of you who don't know, and I'll describe a little more about that in my presentation. But the presentation is not exclusively focused on how do you do a deployment for an AGV. I use this more as a, hey, let's talk about a real life scenario where a wireless deployment is needed. And what are the steps you follow to make a deployment for that scenario work? But this same set of steps that I'm going to go through can be applied to a variety of other types of situations, right? And you'll see a little more about the specific use case I'm going to focus on. So with that, again, thank you so much for joining. My name is Andres Suazo. I am part of what we call our network engineering services team at Phoenix Contact. And it's a new area that I shouldn't say new, but it's a more focused area in our company that we have been trying to develop more into and provide services for customers specifically focused around some of the technologies that we offer for networking, right? So we are a company that is very proficient at the development of networking products. When I say networking products, I mean switches, routers, wireless devices that fit really well into the industrial world. And we are also developing teams within our company that are extremely proficient at the deployment, design, support, configuration, and a variety of other functions needed to make sure that the customer experience for these products goes well. So with that, I'll be running the presentation today. I'm a senior solutions engineer, and I'm more of a network engineering services consultant. So from an agenda perspective, first, I'm going to do an intro to NES. I won't spend too much time on this. My goal is just to talk a little bit about it. I'm extremely excited about taking a leadership role in this team. And I'm very excited about what we're trying to accomplish for our customers. So I take a little bit of advantage on these presentations to talk a little bit about what we can do, how we work within this team, and what are some of the things that we can accomplish for our customers to help them with the deployment of our products. But I won't take too long. The majority of the presentation will be focused on the AGV examples and the focus challenge. So what is NES? So NES is our network engineering services team, and our goal is to provide IT services for the OT space. A lot of our products are used in applications where we're more of the OT space, and that's the operations technology as opposed to the IT space, which is information technology. And if you think of your IT systems, they're typically, your data centers on-prem that you might have that house your customer information. Maybe they maybe they have your CRM or your sales data. Maybe they handle your employee data, payroll, any logistics that you handle, and all those pieces. It's the concentration of all that information. They handle the computers of your employees, and any issues that happen with the network of the people that work for the company. When you look at the OT side, operations, that's your livelihood, right? So in the case of this example, think of an automotive company, the production of cars. That is what we consider the OT space, the operation side of things. And they are two separate worlds, although I will say those worlds are beginning to collide a little more often than not. And so we're trying to provide kind of the same type of services that you see in an IT side for networking as it becomes more and more important on the OT side of the business. We're trying to develop strategic partnerships so our customers are utilizing our products more heavily for networking applications. And we are trying to create partnerships with them so that we're not just a product manufacturer for them, but we're really helping them deploy good systems and solutions with our products without having to take on ownership of the entire process on their own. And then it's a conversation about service level agreements. So if you're from the IT side, this is a very common term in the IT world, but a service level agreement is more or less a commitment of support from vendors, and it is a model for support, for advanced level of support based on a customer application. It's extended warranties on hardware, and it covers a variety of different things to make sure that at the end of the day, if you have a critical system that needs to work and needs to be that you need to make sure that it has the highest reliability, you have a team that you can call and ensure that you can get higher level support in a quick time frame. So from a capabilities perspective of what our team can do, we focus around 6 different core topics: assess, design, configure, document, support, and training. So I have a few slides on this piece. Again, I won't take too long on them just in the interest of time. But when we talk about assessments, so we know that our customers are constantly getting engaged in a variety of different applications. Cybersecurity has become a really hot topic in the world of industrial automation. It's become a hot topic in the world of networking, especially in OT side. You know, and think of recent hacks in the water industry. In Florida, for example, there's situations that your system needs to be better protected, better defended, and there needs to be a better corporate strategy for protecting your operations system side of the business. So assessments are typically a good way to start when you want to look at a cybersecurity portion of your company, and we are engaged with some of our customers in performing some of these assessments. Wireless surveys is another big area where we can do assessments, where if you want to do a deployment of a wireless network in your plant or in a large district, then you may need to do a wireless survey to make sure that where you are installing radios for connectivity is going to meet the needs of the application you're trying to put together. The next one's design, right? So we have a variety of networking products that are capable of performing different functions. When you think of a design of a networking system, some of these designs can get extremely complex, especially as you try to deploy strategies for segmentation, for remote connectivity, for security. All these things create the need to develop a proper design of a networking system. So we're engaging our customers in the ability to do near and long-term goals. So the deployment of a system today, as well as a rollout of a deployment over the next 2 to 3, 4, 5 years, whatever the customer's rollout plan is. And we create a lot of documentation that goes along with it so that customers feel comfortable with what they're putting in today and how it's going to be understood by the next teams that are going to be working on that application. Oh, I think I went backwards, sorry. The next one is configure. So configure is also some of the functions that our team is able to perform. So we can configure the products that we are creating designs for. So if a customer is buying a variety of our systems or our routers, our WLAN devices, and we build a design, or maybe they already have a specification written about how the system is supposed to perform, then we're able to provide configurations for those devices based on a specification. And we can take it to the next step, make some box builds for customers if they are looking for that kind of service as well. So it's a variety of different options that exist for these types of applications. The next one is documentation. If you look at what a services company provides for their customers, documentation is one of the most important differences between when you pay for a service and when you receive something for free, right? So when you're paying for a company to do a documentation on your network, you're trying to understand what are the troubleshooting needs of your system, how are you going to address any problems. If somebody from a C-level wants to review the changes that are going to happen, good documentation is required to do that. And just managing change, right? So when you're deploying hundreds of devices out in the field, how do you make sure that you have consistent configurations or consistent information about the systems that are out there currently deployed? So those are extremely important pieces of a networking design that ensure that you have a good, reliable system moving forward. Support is probably one of the most important areas where we also provide services for, and that's in the world of service level agreements. Now, I could spend probably an entire presentation talking about service level agreements, but for the purpose of this presentation, I'm just going to touch on it briefly. These are very common agreements that are in play in the IT world. But service level agreements are basically commitments between, say, a manufacturer and a customer on our ability to provide support for their specific application. When we do service level agreements at Phoenix Contact, we engage a customer on their network. We understand it. We provide or we create plans for remote access strategies so that when a customer calls and says, hey, my line is down, I need somebody to help me fix it, we have teams of people that are prepared to review the customer system, connect to it remotely, and support them on either a migration to a new piece of hardware if the hardware is damaged, support with the system that they're deploying if there's a configuration change that happened, or if there's a need to replace the hardware to provide an advanced replacement for that piece. But it goes beyond that. It also is a discussion about management software. So when you're deploying a lot of devices out in the field, having a management software that is going to take care of firmware updates for your products, configuration changes, maybe run a few diagnostic details on the devices that are installed is part of that support package that we can help deploy with customers to make sure their networks are being worked on efficiently. And the last one is training. So when you think of a new system that's being deployed, or even the technologies that a lot of our customers are implementing, training becomes a really important piece. This has become very apparent in large organizations that we've done business with in the past, where they have many facilities that are deploying a very similar architecture that was designed in conjunction with us, but they then want to train those teams in how to work with those systems, how to connect them to their upstream plant management software, how to go out there and work with these systems and understand the technology that is also being deployed in their factories and facilities. And so training also becomes a service offering that comes along with a variety of these packages that we're providing for customers. Again, all around the idea of customers are buying our products, or customers have a complex networking application on the operations side, and they would like a company to come in and help them support on the variety of these different types of services that we can offer for networking systems. But enough of that. Again, I'm just very excited about being a part of this team. So I take an opportunity to talk a little bit about what we can do for our customers when it comes to networking deployments and what services we have available. But for the purposes of this presentation, you're here to learn a little bit about how to do a wireless deployment. Now, I will be the first to admit that the topic of the presentation is extremely wide and varied. There is a variety of things that need to be considered when doing wireless deployments, and I don't believe that an hour is enough time to dive into all the different types of use cases that you might face when you're doing a wireless deployment. So instead of doing everything and anything and not focusing on nothing, then I decided to do it a little bit more focused around a services application that we got involved with one of our customers that really provided us a lot of guidance into how to do a specific type of wireless deployment, and I'm going to focus that a little bit more. So first, we're going to talk about the type of customer that we interfaced, and this type of customer was an AGV. And then I'm going to describe it from the OEM side of things and what does that mean. And then once I describe some of the prospects of this type of customer and some of their challenges, I'm going to do a little bit of a focus on one type of situation that they faced and how we resolved it, how we provided the steps for resolution or for the deployment of the wireless application that they had in mind. So first, let's talk about an AGV. So what is an AGV? So an AGV is an automated guided vehicle. And if you think of this, it is a system that is developed by a manufacturer, and it's more or less a robot. It's a robot that has a small control system on it that tells the device where to go and how to move around a building based on a variety of different parameters. It could be that it's following a track. It could be that it is looking for walls and making sure that it's not running into walls in a specific region. Maybe it has a program that it has to visit 5 different stations as it goes from one location to another doing transportation of materials. So it's a system that typically travels along a specific area. And one of the key portions of it is that it is without an operator, right? So it is a robot. It doesn't require the need for somebody to constantly be handling the location where this robot is going. And that's particularly important to the world of AGVs and automation and where they're used. One important factor of an AGV, and if you think about some of the applications where you typically would use an AGV, is its need to use a wireless system for communication. So if you think of some of the applications like warehouse management, like storage retrieval, think of Amazon, right? And all those little robots that are going from one location to another in the entire warehouse, picking up packages, moving them from one location to another. Or if you've ever been to a automotive manufacturing plant, think of all the different lines that have pieces of assembly for a vehicle and how there's basically robots bringing in parts and components to each one of those pieces. Or think of a raw materials processing plant that it's grabbing raw materials from one location and bringing them to the area where those materials are going to be processed. It can become very complicated, particularly depending on how these tracks are laid out, to have a wire that moves along with a robot, right? So wireless connectivity for this particular type of application becomes extremely important for the deployment of these systems. So when we talk about OEMs, we are referring to original equipment manufacturer, right? So these are, again, the focus of this presentation is around OEMs because that is the particular area where we provided this specific service. And OEMs have certain responsibilities when it comes to the development of an AGV. They are responsible for the production and manufacturing of the AGV, and they are doing this for their end customers who have very specific needs of how these AGVs should function. They are also responsible for building the controls platform that controls the AGV's movements. So if the AGV needs to follow a track, they need to have a control system that does that locally with the AGV, that allows the AGV to function by itself, but also to communicate back to a central system information about its location, what it's doing, where it's going, or receive instructions of where it needs to go next from that central location. And then they're also responsible for the connectivity of that device into a customer's network. Now, again, for the purposes of this conversation, we're going to focus on this piece of determining the network connectivity at the end customer. And there are some challenges that come along with it. And this is kind of what I meant when I said I'm going to focus it a little bit more on a specific challenge. So when you look at a deployment of an AGV in a customer's network, here are some of the problems and challenges that an OEM faces in the world of selling AGVs to their end users. First, it's whenever they have a situation and it's an AGV being installed in a new building, right? And it's brand new building. There is no wireless network already installed. It doesn't exist. and they have to provide an AGV into that atmosphere for their application. Then there is a wireless network not using an end user's network. And what that means is, think of a situation where, the customer, the end user, has a wireless network, but the AGV itself is not necessarily going to connect to that end user's network. It maybe is going to have its own dedicated network because it needs higher reliability or whatever the reason may be. It's going to have its own dedicated network. And the last challenge and need from the end user's customer, or from the OEM's customer and the end user, is going to be the need to have a wireless network, but they want it to be with their own, or integrated into their own existing network, right? So if you're thinking about installing an AGV in a new building, in a building from your end user, and they already have a variety of wireless devices and access points that they want to connect these AGVs to, then this is another type of challenge that needs to be addressed by an OEM. So let's dig a little bit deeper, and I had this graphic that I wanted to use at some point during my presentation. I didn't know when it would be an appropriate time to use it, so I decided to put it on this slide, just because I thought it would be a little bit funny. But wireless technology can come with a lot of challenges, right? It is a phenomenal technology that allows us to be flexible in a variety of different applications that we work on. However, there is sometimes a little bit of a mantra of I wonder how it's actually working, and that can lead into a lot of trouble if it's not addressed appropriately. So diving a little bit deeper into the types of challenges that an OEM faces. So the first challenge we talked about was a wireless network in a new building. Typically, this is the easiest type of deployment. The reason that's the case, and maybe this will give you a little bit more background on the other two, is when you are installing a wireless network on top of somebody else's network, or in connecting to two different types of networks where there's two different stakeholders owning those networks, there's a lot of challenges that come with it. There's a lot of interference that can happen. There is compatibility issues. So whenever you have a blank slate, there is no wireless that you have, no other wireless system you have to worry about, and you have the ability to control both the access points and the clients that are being deployed, it produces a scenario that is rather easy to deploy a wireless system. In this case, you get the ability to control both the access points and the clients that are going to be used in a specific location, which makes the implementation challenges a lot lower. Another type of use case or situation that these AGV OEMs are facing is going to be a wireless network where they are not using the end customer's network. Now, this is a little bit of a harder deployment, and the reason behind it is so you're still able to control the access point and client, which is good because it allows you to have compatibility between which access points and which clients you're using. You'll see why that could be a challenge on the third scenario. But when you have two separate types of devices for the access point and the client, now you have to worry about compatibility, right? Does the access point or the client support the same type of wireless connectivity so that they can talk to each other? Are there going to be special protocols supported by each radio that are not supported by the other radio, right? So controlling both the access point and the client makes it a little bit easier for you to not have to worry about some of those compatibility challenges. However, it does raise the risk for a network collision. So when you're deploying a wireless network, there are specific bands that are available for you to communicate on. And if there are too many devices communicating on that same band, you end up having collisions, right? It's kind of like a highway. It's a dedicated highway for information to flow from point A to point B. Well, what happens if you have another piece of data, think of it like in a situation of cars, right? What cars are going one direction on a highway. Well, what if somebody else decides they want to use the same highway to go the opposite direction? Well, all of a sudden you're going to have two cars colliding with each other, and data is not going to be able to get from point A to point B efficiently. And those are some of the things that you have to worry about when you are doing a deployment in an end customer's network, where we're controlling the access point and client, which is good, but you have to manage how those devices are configured so as to avoid interference with the existing network. And then the last type of scenario, which in my opinion, and some may differ on this, is the hardest, is when you have to create situations where you have a client that is defined maybe by the OEM and an access point that is defined by the end customer. This is challenging because of a couple different levels. One is, as we discussed earlier, compatibility, right? So you have a radio from one manufacturer or a client from one manufacturer and an access point from a different manufacturer. And that can be difficult to manage because there might be incompatibilities in the type of technologies that support those systems. However, there's an even higher challenge of ownership, right? So if you are, for example, an OEM that is trying to provide an AGV to the customer and the customer says, well, you've got to connect to my wireless network. Well, now the OEM is at a challenge where they cannot fully provide the reliability of the system because they don't control the whole wireless system. So who takes ownership of it? Is the OEM liable if the system all of a sudden starts working? Is it the IT department? Who takes ownership of that system? And that create really big challenges, particularly when something doesn't go right, because what you end up having is a lot of people pointing fingers at each other. And so for me, this is the hardest type of deployment just because of that challenge with ownership of that system. A lot of times you'll see an OEM provide the devices and let the customer figure out how to connect them together. And that's not a good customer experience, but it's also challenging for the OEM to put their name on the hook to say, oh, if the system doesn't work, I'll fix it, because they don't have the control of the access point as well. For the purpose of this presentation and just in the interest of time, I'm going to focus it on the wireless network where the OEM is, or the person who is doing the installation of the wireless system is defining both the access point and the client, but it is also being installed into an area that already has an existing network in it. So we're going to focus on this wireless network, not using an end customer's network. And you can start to see how even though this is a use case around AGV applications, it doesn't apply only to AGV applications. I like to use the AGV example because it provides kind of a view into or a related situation or something we can use as an example of why this is a challenge. But this set of steps that I'm going to go through apply to any situation, right? Think of a school, right? If you're going to maybe put a set of machinery in a school for what's a good example? Let's say you're putting a new boiler room, right? And the boiler systems that you're putting together, they all need to connect to their own wireless system. Well, guess what? There's already a wireless system already deployed throughout the entire school for connectivity. Well, then how do you put together your own wireless network in that environment without affecting the existing school network? And that would be another example of where you would need to follow a certain set of steps to make sure that you are doing a proper wireless deployment. But again, for this presentation, I'll focus it on the AGV side of things. So when you're doing a deployment, and again, this is spoken out of our experience in working with AGV manufacturers to deploy this into their applications, our first step is to do a collection of information. So the first step you need to do is figure out, well, how many clients are you going to need in this specific network that you're developing? In the AGV example is, well, how many AGVs are you going to have? Because each AGV is going to have a client radio installed on it. And I keep mentioning access points and clients just to clarify that. An access point is kind of the top radio that every client connects to send information, and a client is the end device that needs to be connected to the upstream network. Excuse me. So first, you collect how many clients are you going to need. Then you determine the requirements of connectivity. So how fast you need the data to flow, what is the round trip of that packet. Some of this information you may have to do a little bit of testing to understand or review your own specific application. You know, how much time can your device go without sending information up to an upstream system? I mean, if you need a really reliable connection because your data is critical that it reaches your upstream controller or upstream SCADA system, then you're going to want a fast data trip or fast network connectivity. You're going to want a fast round trip. And you're going to want a lot of secondary coverage, right? So if you lose the connection to one access point, can it fail over to another access point? Those are all questions that are very dependent on the application, but it can help you determine particularly how many access points you're going to need in a network. If you want a lot of secondary coverage of your devices, and what that means is if you're losing signal strength, when should you switch over to another area and what should be that threshold? Well, if your device can spare a few seconds of not being connected, maybe a few minutes of not being connected to a radio, then you could have a couple dead spots and it's okay. The end device will survive. But if not, then you need to add more access points, right? So that kind of information helps you determine how your coverage is going to be laid out. Then you need to determine your area of coverage. So for an AGV example, you typically grab a floor plan and you do an area of wireless coverage. Again, not specific to AGVs. This can be used for any type of application. But you need to determine what area do you need this specific network to provide connectivity for. And then the last thing, which is very important for this type of use case, is to collect information on the existing network. So as we've been discussing, there is a network already deployed in the customer's environment. They have a variety of access points that are broadcasting their information for connectivity on specific bands. So you need to collect information about how strong are they broadcasting this, and what radio bands are they utilizing when connecting to the network. Are they using 2.4? Are they using 5 gig? And are they using, which channels are they using to connect and communicate with the end devices? That'll become very important when you lay a new wireless system that is potentially right next to that same wireless system, and make sure that there's no problems with connectivity between one and the other. The next step is to develop a theoretical survey. So what that means is, again, you have a floor plan and you can use, there's a variety of tools out there in the market that allow you to download a file with a floor plan that can be it could be a PDF file. It could be what's the word I'm looking for? A CAD drawing of a building, for example, and you can, from that building, create kind of a layout of an area where you need coverage and overlay a wireless network on top of it. So theoretical surveys are very important to understand, one, a bill of materials. So how many radios are you going to need to provide the coverage that you need? And as a first step to this theoretical survey, you first kind of create a heat map to cover the area that you want covered for your application with the requirements that you need. Here's where it becomes important to know, what is the round trip time, what is the data speeds that each device should be seeing, because based on that information, this theoretical model can tell you how many access points will be needed in this particular location to meet those requirements. And it provides you a bill of materials so that you know how to do an installation, and it gives you a roundabout area of where this access point needs to be installed to make sure that this network and this system is working correctly. The next step is to create a heat map for the existing network. This is also very important so that you can understand when you're designing these systems, what the environment looks like already. Where are these access points located, and what are the configuration parameters of those access points? That'll help you determine and make sure that when you're overlaying your own network on top of it, you're not causing any interference with the bands that those devices are using to communicate. And the last step is to kind of combine these two models. And here is where you grab your, for all intensive purposes, inflexible existing network, because the goal is to not change that network, and to add on top of it your own network to verify that there's no interference between the two. And again, this is all done from a theoretical perspective. The third step is an on-site survey and validation. So this, I will say, is probably one of the most critical steps in developing these wireless systems, because at the end of the day, you know, the information is only as good as oh man, maybe that's not exactly how the saying goes, but you get what I'm saying. The information that you are using is only as good as as it is being provided. And what that means is, sure, a customer may tell you that they have access points in these specific locations, but how do you know that those access points are actually there? The only way for you to know that is to go and do a site survey and do a validation of that information. And what that means is verifying that structures were there and that the access points are in the locations that was described. Structures are particularly important because if there is a big metal structure in between the path that you're trying to walk, one, the AGV won't be able to go through it, and two, you're actually going to get a lot of radio interference, which may modify the way that you have to lay out your network in order to ensure connectivity. You may need to analyze the frequency of the air, or you may need to analyze the network with a tool that allows you to kind of like a spectrum analyzer to ensure that there is no unknown devices producing data that you may not be aware of. This can help you make sure that there are less problems that happen when you're doing your deployment. And finally, one of the bigger steps of a site survey is going to be the idea of doing a full test procedure using something like an AP on a stick. And what that means is you'll grab a few set of radios, you'll place them up where you expect to have your own radio network to be deployed. You configure those radios as your theoretical model described, and then you run an AGV, or you run a little cart with a tool like a JPerf to be sending traffic back and forth between two endpoints, so that you can collect some data on what that network is going to look like once it is deployed. Again, this is probably one of the most expensive parts of a survey, but think of the amount of time that you could save during the deployment phase if you're able to test out and have a good baseline of how this network is going to behave once it's turned on and you're ready to commission and do your SAT testing or your site acceptance test to move forward with the deployment of your system. And then of course, once you perform all of these analysis and reviews on the existing installation, it's important to go back and reevaluate your original assumptions, right? So maybe you may have to move a few access points from where they're going to be located. You may have to change a few of the channels that they're producing data on, or reduce the amount of power they're using to broadcast their SSID. You may have to make a few changes, but it's important to do it after you've done some of the site survey pieces that are needed. The fifth step is configuration and deployment. So again, this is part of the particular application that we got involved in, where we also provided the configurations for the products. So you go out there and you configure those devices based on the specification that you created. And then you do the installation. So those radios get officially installed with power. They get turned on. They get configured as they need to be. They start producing their SSID. And then you do the validation, where maybe you grab one AGV or one device and you walk around a track, you walk around an area, and you verify that the device has the expected connectivity that you wanted. And then of course, with any deployment, there might be a need for some troubleshooting. We particularly offered an on-site survey or service where we were on site for the SAT to verify how that connectivity was going. The final step is training and support, right? So with everything, the ability for the end customer to take ownership of their system is extremely important. So training that is defined either with the OEM or the manufacturer to do a customized training on the installation they received or on the technology itself is important in the customer taking ownership of that system that is installed. This is beneficial for everybody on the chain because you receive a customer that is not necessarily calling you all the time to ask you questions about how this system needs to be functioning based on the way that it was installed. And then defining support models, right? So again, we talked about SLAs that are available from manufacturers like us, or even from the OEM that is providing the devices that are going to be installed on your network. It's important to define, if it is a critical system, what do you do if something does not work? Who do you call to troubleshoot it on the different types of situations? And how do you ensure you have a support strategy defined so that when things are not working, you know where to go to get your system back up and running quickly without having to experience too much downtime. So that's it from a steps perspective of how you go through a deployment. A couple tips that I think are very important to consider when you're going through this. One is engage your IT department, right? So IT departments are more and more engaging in some of these OT operations, and a lot of wireless deployments are managed by IT. And so in order for you to deploy a wireless network efficiently, it's important to discuss with the teams that might already be deploying their own wireless systems. If you have too many people trying to deploy wireless systems in the same locations, you're going to have problems. So it's better for everybody to be kind of working together. I know it can be a little bit uncomfortable because it's sometimes challenging to work with IT teams. They function differently. They have different expectations and requirements. But there is value in having both teams collaborating and talking to each other, and it is extremely necessary for this type of application where you're deploying a wireless system inside of another wireless system. Collect and verify as much information as possible. This is if your system did not work when you fully installed it, it's probably because the information you collected was not accurate. So collect and verify. That's extremely important when you're doing these types of deployments in order to make sure that that your deployment goes well. And then gauge your needs for services. So we talked about 3 types of use cases. One being, deploying a wireless network in an area that is completely brand new and doesn't have any wireless devices already existing. Well, you know what? You may not need that many services for that. I mean, you may not need to go the whole way through testing with APs on sticks and paying for a very complex system to be designed, because the risk of having problems in that network, in that environment, are rather low. Now, that being said, it's also a question of how expensive is your downtime. If your downtime, I've heard of customers that have, $100,000 day downtimes or even more. Well, if you're losing $100,000 a day for having downtime, paying for a survey that is going to be a tenth of that cost for a full-blown survey is better than having to experience that kind of downtime. And as concluding thoughts, and maybe Justin, I'll ask if you can put me back on the screen just to do my conclusion pieces. But managing a wireless deployment, it requires preparation. So you can't just decide one day to put up a wireless system in a network and hope it works, right? And if you do that, well, at least in our building, if we do that, somebody from IT very quickly calls us and says, "What's this device that's going on?" or shuts it down, or tries to dig into finding out who's putting up wireless devices around their network. So it requires preparation. It's important for for different teams to get together and ensure that they're communicating, and ensure that you're doing your due diligence and hiring the right companies to help you do surveys and analyze the location where you're installing these devices. You can follow the steps to develop a confident plan, right? So the purpose of doing everything that we're doing is to provide people the ability to deploy a wireless system and avoid as many issues as possible. Again, once you're expecting to have an upstart time of a specific date, every day that you miss from that one kickoff date is money lost. So the more you can do up front to avoid that kind of situation, the better your long-term goals are able to be met, and the more effective your kickoff of your systems are as you go forward. And then engage a professional service provider. So a lot of these things are not core competencies of individual companies, right? So a lot of AGV OEMs, they don't focus on how to do a wireless deployment. They focus on how to build an OEM or an AGV. They're extremely good at it. They focus on building the devices that they promote to their market. Going out there and becoming a wireless survey company is not really what their core business model is, nor is it for a lot of other OEMs out there or even end customers. So hire a good professional service company that can help you perform some of these wireless services needed to do a comfortable and confident deployment. We at Phoenix Contact do offer these services. So if you have an application or an opportunity, then it's something we can definitely entertain to help you out and see what we can do. So that's all I had. If you have any questions for me, here's my email address. Feel free to email me. I appreciate everybody's time. And I guess at this point, Justin, do you have any questions that came up on the chat for me to answer?
Nothing in the chat that wasn't answered privately. So I think we're all set, Andres.
Okay, awesome. Well, thank you, everybody. I appreciate your time, and I appreciate coming over to see this presentation. If you have any feedback or anything, please feel free to reach out to me at any point, and I'd love to hear from you. Hope everybody has a great day.